A pleasant good day to you. The last time I was here, I shared with you the Arduino Fundamental Exam Starter Kit. And I have since created the first circuit, the first project in that book. Using the kit. But before I show you what I created, I just want to talk to you a bit about circuits. The first project involved creating 3 projects. A simple circuit, a series circuit, and a parallel circuit. Now, what are circuits or how circuits work? I just want to share with you a little about circuits. The first thing is that there needs to be a complete path for your circuit to work. So you must have a complete path from your power source to an area of least resistance or the ground. All electrical energy within a circuit is used up by the components within that circuit. Each component takes electrical energy and converts it to some other form of energy. For instance, the resistor breaks down the current. It takes some of that current or that electrical energy, and it converts it into heat energy. The flow of current at a specific point in a circuit will always be the same, going in or coming out. Electricity always seek the path of least resistance. So it flows from the power source, your battery, whatever you're using to supply your electricity. It flows from that point to the ground, and the ground is the negative, is the point of least resistance. So in this project or in this circuit, we'll be using the Arduino board to supply the power. And that power will be supplied through my laptop into the Arduino board and then back into the breadboard, and it will light some LEDs. So I'm using the Arduino Uno, the breadboard, LEDs, some jumper wires, a couple of switches, and some resistors. So an LEDs are polarized. They are polarized components, which means that they allow electricity to flow through them in one direction. The longer leg on the LED is the anode, or the positive side of that LED, and the shorter leg is the negative or cathode. A resistor, like I said before, resistor is a component that resists the flow of electricity. It converts some of that electrical energy into heat. So now that I have explained that, one other thing that I want to explain is a little about the breadboard. So I have this breadboard here. So now your breadboard is divided by this part. The breadboard is actually not connected. The two sides are not connected. So we have a positive and a negative strip here. And then we have these connecting wires, or it is actually, if you open the back of the breadboard, you will actually see metal strips running across, and metal strips running along the back for the positive and the negative. So the positive is one metal strip, the negative is another metal strip, and then you have metal strips running across each of the numbers. So the numbers are the same. The letters on the breadboard differs. All right, what does that mean? If I'm going to connect an LED, I would want to put one leg of the LED into one letter and into one number, sorry, and the next leg into another number. All right, so the letters and the numbers differ, right? So this is what we must know. So we can also connect the two sides of the breadboard by running a jumper wire from the positive on one side to the positive on the next, and from the negative to the negative, and that will bring current. Once we bring current into the breadboard, that will cause that current to be shared throughout the entire breadboard. All right, so now that I have discussed that with you, I am going to show you what I did here. So I have this connected to the computer. I did all three of the projects on one breadboard. So the first one here, if I click this, if I press this, it turns on the green LED. So the circuit is completed once the switch is pressed down. What a switch does, the switch interrupts the flow of electricity, or interrupts the flow of current, of your current that passes through your circuit. So the switch interrupts that flow. So once the switch is pressed, that flow continues through the entire circuit. So the next circuit that I created is a series circuit, and this one I have to press both of these switches here for the red LED to come on. If I press one switch, nothing happens. If I press the next switch, nothing happens. I need to press both switches and that red LED will light. My third is a parallel circuit. So in this parallel circuit, I just need to click on one of these switches. So anyone will light that LED. And many of us have seen these types of circuits in our home. We might have a light bulb in our home that can be turned on using two different switches. So that is what a parallel circuit is. So if we look here, I don't know, I know that I made it a bit confusing because I wanted to put all the projects from, or all the circuits from project one onto one board and I just made it one time. But if we look here, we can see that the current will flow from one end of this switch to the next end of that other switch. So it is flowing from the positive end of one switch to the positive end of the second switch. Then the current again from the negative end of the second switch to the negative leg of the LED, and from the negative end of the first switch to the negative end of the LED, and then we have a wire connecting to negative, and we have this resistor connecting to the positive. So that makes the circuit complete. So if I press one or the other switch, then my LED comes on. And what is happening there? The LED is converting that electric energy into light energy. So once I click it, the electric energy is now converted to light energy. All right, and again, I want to go over the second one. I must click both switches for that red LED to come on. And the first one, a pretty simple circuit. We have just one switch, and from the positive end of the switch is run to the positive end of the LED, and we have a resistor, and then we have a negative which grounds off the circuit. So once I click on this, then it lights up. So that was project 1, guys. Please tune in again for more videos as I complete this other books. And please remember to like my videos, comment, let me know what you need. If you need some more information, please let me know. All right, have a great rest of your day.